Good day everyone, welcome to Max Facts First Class Tutorial YouTube channel. So in this particular video, we are going to be talking about a dimension and dimension analysis. So before you dive in fully into dimensions and dimension analysis, we have to talk about the fundamental quantities. Basically, we have 7 fundamental quantities, but for the sake of this video, we are going to be talking about 3 fundamental quantities. The first 3 fundamental quantities are length, time, mass. Then once you've known the first 3 fundamental quantities, the next thing you have to note is that the unit for length is meter, but the dimension for length is L. The unit for time is second, but the dimension is what? T. The unit for mass is kilogram, but the dimension is what? M. So for the sake of this video, we are going to be talking about some derived quantities, the units of some derived quantities, how they are being derived, and their dimension. So let's start with the first one, which is area. Area. Before we can talk about the dimension or the unit of any fundamental quantity, we have to talk about the formula. What is the formula for area? The formula for area is length times breadth. Since the formula for area is length times breadth, then this simply shows that the unit for length is meter. What of the unit for breadth? Then the first thing you have to know now is that whenever we are talking about breadth, height, distance, displacement, they all have the same unit and dimension as length. So this simply means that the unit for breadth will be the same unit for what? Length. So therefore, the unit of area will be meter times meter, and that's what? Meter squared. The dimension for length is L. So whenever a particular quantity has the same unit as another quantity, it will also have the same dimension as the other quantity. So therefore, the dimension for breadth will be the same dimension for length, which is what? L. So therefore, area, dimension for area will be what? L times L, and that's what? L squared. We also have the volume. The formula for volume is length breadth times height. The unit for height and breadth would be the same unit for length, so as the dimension. So the unit will be meter times meter times meter, meter cube. Dimension will be L times L times L, L cube. We have the density, which is mass over volume. The unit for mass is kilogram. The unit for volume is meter cube. I can split this kilogram over meter cube as kilogram times 1 over meter cube. If this, I can write this 1 over meter cube using the indices law, then this meter cube we go up, then this division changes to minus, so that will be kilogram meter raised power minus 3, or you say kilogram per meter cube. Then you have to know, you have to be very careful here. If you are using this minus, you must not put the division sign here, but once you put the division sign here, you must not put the minus here, and the reason why is because it is a division sign that changes to minus here. The next one is the dimension. The dimension will be m L raised to power minus 3, because the dimension for mass is m. The dimension for m raised to power 3 is what? L raised to power 3. So therefore, this kilogram meter per cube, the dimension will be what? M. The dimension for kilogram, L raised to power minus 3. This L is dimension for what? Mass. The next one is speed. The formula for speed is distance over time. The unit for distance will be the same unit for length. So therefore, the unit of speed will be meter over seconds. You can say meter per seconds or meter per seconds. The dimension will also be L raised to power minus 1. Since the meter is here, the dimension for this meter is L. Seconds, the dimension for this seconds is T. We can also have the velocity, which is displacement over time. Unit will be meter over seconds, so it can be meter per second or meter per second. Dimension will also be what? L raised to power minus 1. Do not forget that displacement and distance, they have the same unit. So this simply means that speed and velocity, they have the same unit. We also have the acceleration and velocity over time, and that is the unit will be meter per second, which is a unit of velocity all over unit of time, which is seconds. If this second goes up, then this s over minus 1 is going to to meter s raised to power minus 2, meter per second square, and the dimension would also be lt raised to power minus 2, since it is meter per second square. So let's So the next thing we are going to be talking about now is the force. Now don't forget that you cannot know the dimension or the unit of a particular quantity without knowing the force, the formula. The formula for force is mass times acceleration. So therefore, the unit will be kilogram times meter per second square, and the reason why is because the unit of mass is kilogram, the unit of acceleration is meter per second square. So therefore that will be kilogram times meter per second square, and that's what? Kilogram meter per second square. So if the unit is kilogram meter per second square, so therefore the dimension would be ml t raised power minus 2, because the dimension for mass is m, the dimension for acceleration is l t raised power minus 2. And the next thing you have to notice is that the SI unit for force can be Newton, so therefore Newton can equals to what? Kilogram meter per second square. The next thing you have to notice is the work and energy. The first thing you have to understand about this is that work and energy have the same formula, hence they will have the same unit and dimension. So the formula for work and energy is what? Force times distance. So we can have various units of work and energy. The first one can be, since the unit for force is Newton, distance is meter, the first unit can be Newton meter. Since the unit for force is kilogram meter per second square, and the unit for distance is meter, the meter times meter will be meter square. So the other unit for work can be kilogram meter square per second square. So therefore the dimension will now be ml raised power 2 t raised power minus 2, because this mass, this kilogram is the mass, the dimension for mass is capital M, this meter is the length, the dimension for length is L square, and this seconds is the time, the dimension for time is what? T. So that is why the dimension for work and energy will be what? ml square t raised to power minus 2. Then you have to know something, that the SI unit of work and energy can be joules. It can be joules. So therefore you have to know that the joules can equals to the Newton meter. It can also equals to kilogram meter square per second square. The next thing we're going to be talking about now is the power. The formula for power is work over time. The unit for power also, we have various units for power. The first one can be joule over seconds, and the reason why is because the first unit for the SI unit for power or for work is joule. So since this is work and this is time, it can be joule over seconds, and it can be written as what? Joule per second. The other unit for work is Newton meter. It can be Newton meter over seconds. Then these seconds can go up. There can be Newton meter per second. The other unit for work is kilogram meter square per second square. It can be kilogram meter square per second square over seconds. These seconds can go up. Then it turns to kilogram meter square per second cube. The dimension for power can then be ml square t raised power minus 3, because this kilogram meter square per second cube, which is the unit for power, the kilogram is mass, the dimension for mass is capital M, the meter is length, the dimension for length is capital L, and the S is time, dimension for time is what? Capital T. So you have to know something, that the unit for power, which is watts, can equals to the first unit for power here, which is joule per second. It can equals to Newton meter per second, and it can also equals to what? Kilogram meter square per second cube. And the last thing we are going to be talking about before moving on to dimension analysis is pressure. The formula for pressure is force over area. Then we can have the unit for pressure to be, the first unit for force, the SI unit for force is Newton, and area is meter square. So it can be Newton over meter square. That can be written as Newton meter per second square. So you have to know that this Newton is also equals to kilogram meter square per kilogram meter per second square. So that is why we can rewrite this N as kilogram meter per second square times meter raised power minus 2. So if I should multiply this meter by this meter raised power minus 2, it's going to turn to meter raised power minus 1. So therefore the unit of pressure can also be kilogram per meter per second square. So therefore the dimension will be N per L per T square. This is the kilogram, this is the length, this is the time. So therefore you have to know that Newton meter square is equals to what? Kilogram per meter per second square. Then you have to know that stress, either it is tensile stress or tangential stress, has the same formula as, they have the same formula as pressure. Hence will have the same unit and what? Dimension. So let's talk about the dimension analysis. Now let's talk about dimension analysis. So after we have understood what dimension means, then we can successfully talk about the dimension analysis. What is the dimension analysis? This is the expression of quantities in their dimension form. So it is by expressing quantities in their various dimension form. This can be used to test the validity of an equation or the correctness of an equation. So what do we use dimension analysis for? We use dimension analysis to test the validity of an equation or the correctness of an what? Equation. For an equation to be valid or correct, it must be dimensionally correct. So therefore, for a particular equation to be valid, or before that equation can be said to be a correct equation, that equation must be dimensionally what? Correct. And how will an equation be dimensionally correct? For an equation to be dimensionally correct, total dimensions on left hand side must equal the total dimension on what? Right hand side. So let us look at some example in which we can use dimension analysis to test the validity of an equation, but also note that we can also use the dimensional analysis to derive an equation. So the first example that we are going to be doing is this: test if equation v is equals to u plus at is correct. So whenever they ask you to prove if an equation is correct, what they're asking you to do is to prove if it is dimensionally correct. So don't forget that for an equation to be correct, it must be dimensionally correct. And for an equation to be dimensionally correct, the total dimension on the left-hand side must equal to the total dimension on the right-hand side. So the first thing we are going to do is that the step one always is that write out the dimensions of each quantity in the equation given to you, which is v is equals to u plus at in this case. This v represent the final velocity, this u represent the initial velocity. They are both velocities, either they have the same dimension. The dimension for velocity is lt minus 1, u is also lt minus 1. This a represent the acceleration, and dimension is lt raised by minus 2. The t represent time, and dimension for time is capital T. So that's the first thing you are going to do. You will write out the dimension of each quantity out. Step 2, substitute the dimensions of each quantity into the equation. So you know we have v, we have u, we have a, we have t. The dimension for v is lt minus 1, u is lt minus 1, a is lt minus 2, and the small t, the dimension for time is t rather. So we can then rewrite the expression as lt minus 1 is equal to lt minus 1 plus lt minus 2 times t raised power 1. Because this t and this t raised power 1, they are the same thing. Any t raised power 1 is that thing. Then we can then write it as lt minus 1 is equal to lt minus 1 plus lt minus 2 plus 1. So whenever we have two same base numbers connected together by multiplication will change to addition. So this minus 2, this multiplication will change to addition, then it turns to these two t's turns to 1, then it turns to t raised power minus 2 plus 1. So it will then turns to lt minus 1 is equal to lt minus 1 plus lt minus 1, because minus 2 plus 1 will give us minus 1. So since lt minus 1 is here, lt minus 1 is here, they are connected by plus, they are the same thing, then it can turn to 2 lt minus 1. Then another thing you have to note now is that all numbers, whether it is fractional number, integer number, they are all dimensionless. So therefore our lt minus 1 will equal to what? Lt minus 1. So since the dimensions on the left hand side equals dimension on the right hand side, the equation is dimensionally correct. Let's look at another example. Okay, so we are going to be using dimension analysis to test the validity of this equation. Don't forget that whenever they ask you to test the validity of an equation, what you have to do is that you have to confirm if the equation is dimensionally correct, because for an equation to be valid, it must be dimensionally correct. So let's do that, guys. The step one is that write out the dimensions of each quantity in the equation given to us. In this case, the equation given to us is v squared is equal to u squared plus 2as. Write out the dimension of each quantity. The dimension for velocity is lt minus 1. Velocity, in this one, this v is final velocity, this u is initial velocity, but they are both velocities. So the dimension for velocity, this u is also what? Lt minus 1. The acceleration a is lt minus 2. The distance s is l. Then you have to know something. What usually confuses students at this point is this s. This s represents the distance. It represents distance. This s represents what? Distance, not speed. S represents distance. And this s, the dimension for this s is what? Capital L. Substitute the dimensions of each quantity into the equation given to you. So that will then turns to lt minus 1 all squared is equal to lt minus 1 all squared plus 2 times lt minus 2 times L, because v, it is v squared. The dimension for v is lt minus 1. U, it is u squared. The dimension for u is lt minus 1. A is acceleration. The dimension is lt minus 2. And s is the distance. The dimension is L. Open the bracket. So we're going to use the power to open a bracket. That will then be L squared t minus 2 is equals to L squared t minus 2. So whenever you are using the power to open the bracket, the power outside is going to be multiplying the power inside. So if I use this 2 to open the bracket, then it returns to L squared t raised by minus 2, because 2 times 1 will be 2, 2 times minus 1 will be minus 2. The same thing as here, L squared to the raised by minus 2. And here I'm going to use this L to multiply this L. What is 2 times L? That is 2L squared. T raised power what? Minus 2. So this will now be L squared T raised by minus 2 plus 2L squared T raised by minus 2. Since this one is 1, since this and this, they are the same thing. This one is 1, this one is 2. Then this 2 expression is going to change to 3L squared T raised power minus 2. So this will now be L squared T raised by minus 2 is equals to 3L squared raised power minus 2. Don't forget that all numbers are dimensionless. So 3 is dimensionless. Therefore, L squared T raised by minus 2 will be equals to what? L squared T raised by minus 2. Hence, it is dimensionally correct. Therefore, it is valid. So let us look at one example in which we can use this dimensional analysis to derive an equation. So now, we are going to be using dimension analysis to derive an equation. The question is the speed c of an ocean wave is proportional to the acceleration due to gravity g, wavelength lambda, and density rho of the wave, where k is dimensionless constant. The correct equation for the speed of the ocean wave is dash. So how can we approach this? Let's start. So whenever you are using you have a word problem like this, and you have to use this word problem to derive an equation using the dimension analysis method, you have to be following this step. Once you know this step, you won't have any problem with any sort of questions under dimension analysis. The step 1 is that interpret the question and generate a general proposed equation. What do we mean? Whenever they ask you to interpret the question, you will go back to that question and read out the question. So let us read out the question. The speed c of an ocean wave is proportional. Whenever something is proportional, in which they are not indicating whether it is direct or indirect, we are to assume the equation is directly proportional. So therefore, we are going to say that this proportional is what? Directly proportional. So this c is speed. It is proportional to the acceleration due to gravity g, wavelength lambda, and density rho of the wave. So we are going to say that this sign that is here represents the proportional sign right there. So we are going to say that this c is proportional to g, proportional to lambda, proportional to rho. Now we will now change this proportion sign. We are going to turn this to 1 and change it to equality sign. Whenever we are changing proportion sign to equality sign, we are going to be writing a constant number first before we write the word, the quantity. So therefore, c will now equals to k g lambda rho. This sign that looks like p is referred to as rho, rho. So this k and this is equals to is what we changed our proportion sign to. That's how to do it. So once you've done this, then you are going to represent the powers of g, lambda, and rho as x, y, and z. That's how to do it. You are going to be representing, that's what we mean by proposed equation. So you will just represent the powers of the constants of the quantity rather as what? X, y, and z. Actually, you can use any letter that you want. You can use ABC, but for the sake of this video, I'm going to be using X, Y, and Z. So that is why this C now equals to K, J raised to power X, lambda raised to power Y, rho raised to power Z. Step 2, write out the dimensions of each quantities in left-hand side and right-hand side. So in the left-hand side here, we have our C. This C is representing the speed. So the dimension for speed is what? LT minus 1. The G represents the acceleration due to gravity. The dimension for acceleration is LT raised to power minus 2. The lambda represents the wavelength, and the dimension for length is L. And this will represent the density, and the dimension for density is what? ML raised to power minus 3. So in step 3, we are going to be substituting the dimensions of each quantity into this expression. So this C, the dimension is LT minus 1. That's LT minus 1. This G is acceleration due to gravity. The dimension is LT raised to power minus 2. That is LT raised to power minus 2. Or raised to power X. G raised to power X. This lambda is the wavelength. The dimension is what? L. And that is L raised to power Y. And this rho is the density. The dimension is ML raised to power minus 3. That's ML raised to power minus 3 raised to power Z. So step 4, use the power to open the brackets. So we are going to use this power to open the brackets. Then X times L, that will be L raised to power X. X times minus 2, that is minus 2X. Y, L raised to power Y. z, m raised to power z times l raised to power minus 3z. So guys, once we have used the power to open the bracket and we got this expression, then the next thing we are going to do is that we are going to collect the like powers. So how are we collecting the like powers? So the power that are the same, the collect the like terms. Actually, we have to collect the like terms. So the terms that are the same, we are going to bring them together. You will see that in the right hand side we have L here, we have L here, we have L here. We are going to write the 3L together. So that is why we write it as LT raised to power minus 1 equals to K L raised to power X, L raised to power Y, L raised to power minus 3Z. We collect the like terms together. The step 6 is that we are going to use indices multiplication law. You know, in the right hand side we have, in the left hand side we have LT minus, but in the right hand side we have L, L, L. They are the same base. They are connected together by multiplication. If you want to turn these three same base numbers to 1, then multiplication will change to addition. So therefore, the top retains to x plus y plus minus 3z. So plus times minus is minus. That's why it turns to L raised to power x plus y minus 3z. And 3 raised to power minus 2x, m raised to power z. In step 7, since there is m in the right hand side, you see that in the right hand side there is m, we can also write m in the left hand side. All the quantity in this left hand side, in the right hand side, must be written in the left hand side. Since there is L here, there is L here, there is T here, there is T here, but there is M here, there is no M here. So we can bring M to the left hand side. And how can we write M at the right hand side? We are going to write as m raised to power 0, because anything raised to power 0 is 1. So m raised to power 0 is still 1. So therefore the expression here, which is LCS minus 1, we can also write it as m raised to power 0. This m raised to power 0 is 1. L raised to power 1 is still L. So that is that. So we are going to do it like that. So in step 8, we are going to be comparing the left hand side with the right hand side. But we start with m. You know, here we have m raised to power 0. Here we have m raised to power z. We just say m raised to power 0 is equal to m raised to power z. So therefore, this m can cancel this m, and our z will equal to 0. We will also relate L with L. L raised to power 1 from the left hand side will equal to L raised to power x plus y minus 3z on the what? On the right hand side. So therefore also L can cancel L. Therefore our 1 will now equals to x plus y minus 3z. Also t raised to power minus 1 at the left hand side can also equal to t raised to power minus 2 in the t raised to power minus 2x in the what? Right hand side. We can also say t cancel t, then minus 1 will equals to minus 2. Minus can cancel minus, then divide both sides by 2, then our x is equals to 1 over 2. We can then substitute z is equals to 0, x is equals to 1 over 2 into this expression. Then it returns to 1 into 1 equals x plus y minus z. You know that we've gotten the value of z, we've gotten the value of x, but we've not gotten the value of y. So if we want to get the value of y, then we are going to substitute the value of x and z into this expression. That will then turns to 1 is equals to 1 over 2, x is 1 over 2, plus y minus 3 times 0, because our z is what? Is 0. 3 times 0 is 0. So it returns to 1. This 1 over 2 will go to the other side. It returns to 1 minus 1 over 2 is equals to y. 1 minus 1 over 2 is 1 over 2. So our y is 1 over 2. So therefore x is 1 over 2. Y is 1 over 2, Z is 1 over 2. And the last step, which is step 9, is that substitute the values of x, y, and z into this expression that we arrived that we derived in the first step. So that will then be c is equals to k g raised to power x is 1 over 2, lambda is 1 over 2, rho raised to power 0. Anything raised to power 0 is 1. So your c will equals to k root g root lambda times 1. So this will be c is equals to k root g lambda, and that's the what? Final answer, and that is option A. So that is the end of this tutorial video. Do not forget to comment, like, share with your friends, and please subscribe to this YouTube channel.